if the constants of the universe, gravitational, speed of light, whatever, were all tiny, tiny bit different, like different one part in a billion or something, maybe in our daily lives we would not notice. But over the history of the universe, things would be so fundamentally changed that our existences would just not be the same.
Yeah, or we wouldn't exist at all. This is StarTalk Sports Edition. We're going to do cosmic queries today, the grab bag version. I got with me my co-host, of course, Chuck Nice. Chuck.
Hey, what's up, Neil?
Got Gary O'Reilly, former soccer pro. How you doing, Gary?
I'm good, Neil.
This is Cosmic Queries grab bag, which takes us to a broader stretch of the geekosphere than normally I can handle all by myself. And so, guys, we brought in the big guns for this. And who would that be? The one and only Charles Liu, my friend and colleague. Charles,
yes.
Welcome back. We need the crowd noise. Charles, all hail the geek in chief.
Our returning champion.
Still champion. Undisputed.
You are all too
reigning
kind.
champ.
Thank you. It's such a pleasure to be back. Thanks for having me, everyone.
And to put this in context, the geek spectrum, the geekosphere, knows no bounds in its extremities. So, yes, I'm card-carrying geek, and I'm proud of it, and I can hold my own on the street. But if Charles Liu walks in the room,
Now we entered the multi-geekiverse. We have entered the multi-geekiverse. We got Neil and Chuck Liu.
oh my gosh! So Charles, you are a professor of astronomy and physics at City University of Staten Island in New York.
That's correct.
Is that fair enough? And do they still give you administrative duties now, or are you back in...
Yes. Regrettably or happily, I'm currently chair of my department.
Oh, wow. Yes, sorry to hear that. Yeah,
It's a double-edged sword. On the one hand, yes, there's a lot of paper these days, electrons, I guess, that one has to push that one wishes one does not have to push. But on the other hand, you get a chance to really enact change. You can help,
there you go.
The 21st century classroom be what it is. You can design curriculum and move things along better. And so I really welcome the challenge. And I'm very fortunate, too, that my colleagues are great. There's not a jerk or a dork among them, which
and sometimes
many
there
departments,
is.
Many times departments cannot boast that.
I really want to look up the origin of the double-edged sword analogy, metaphor, because, when it comes to killing people, I want a double-edged sword.
Not necessarily.
We use it.
No,
why wouldn't you?
Think about the scimitar. Okay, it's a curved blade.
I know what
it's heavy on one side.
Right.
And as a result, the front side can be very, very sharp.
Right.
And meanwhile, you have much more force going that way. And then you poke in the other direction. So not having the blade actually gives you an advantage because you have a strength of striking in one direction. There's a story that goes that during the Crusades, Richard the Lionhearted tried to demonstrate to the Saracen prince that he was going to just how powerful the Crusaders were. He took his two-sided sword and severed an iron bar with a single stroke because of his great power. And the Saracen prince then came back, brought his scimitar, took a feather pillow, and sliced the pillow exactly in half with the scimitar. You can't do that with a double-edged sword.
But you can't do that with a Ginsu knife, so screw that prince. That prince is not that impressive. And was it a My Pillow? Because, let's be real.
Why can't a double-edged sword cut a pillow in half?
The double-edged sword could cut a pillow in half, but it was not built to cut a pillow in half. And as a result, it was built for strength and power, but there was no subtlety to it. Right,
not precision, no precision.
No, it was the broadsword, and it was meant to be used to fight against soldiers or knights in chainmail armor.
That's right.
Therefore, the scimitar's not going to poke a hole through the metal.
If I can't cut through the armor, I'll just break your arm.
Yeah. Right.
Pretty much what it was.
But what the scimitar can do is basically scalpel things, surgically remove limbs and things, digits, in such a way that you can be as armored as you want, but you still can't do what you want to do.
See, but here's where
Damn.
where I go back to my point. Why not just have a double-edged scimitar?
Because
And
the
now
because the second edge reduces the ability of the first edge. It's a trade-off between one side and the other.
Okay. Well, you're a real know-it-all, ain't you?
I know.
Guilty as charged, Sir Lord Nice.
You know, you should
Thank
be
you.
on our podcast, you know?
Yeah.
Oh, okay.
You think?
Oh, that was fast. That was good shit. I'm
All right,
sorry,
so we
guys. Sorry.
got questions from our Patreon members, and this is a grab bag, so it's anything in sports, right? Science and sports.
I think you just end that sentence at it's anything.
It's anything. Okay, let's go with it. This is sports edition, though, so we can put a sports spin on it. So, Chuck and Gary, you got the questions, but bring it on, and I'll help out like when it's my turn or when I think I can help. But
you'll be involved, Neil. Guarantee you.
Generally, I am unnecessary in the presence of Charles. Just
No,
to
no,
make
I'm
that
not
clear.
worthy. No.
All right, well
Okay.
let's kick off
Go.
the first one. Dan Rez, and thank you to all our Patreon patrons for involving themselves in our request for questions. So here we go. I have another question because this is one of several that Dan decided he'd drop into our inbox. If time is a constant but is affected in a way by gravity, is there, theoretically, a way to manipulate time? If gravity waves can affect how time moves and speed can make time move either faster or slower depending on vantage, and he says in brackets, I guess, is there a way, obviously, theoretically, to manipulate time? Also, is there a correlation in size and time? Let's say, hypothetically, there's an object or being that is bigger than the universe itself. Would time act differently due to the larger mass, and would this thing experience time as we do? And does the fact that the size difference allows for faster movement also perception of time to said thing or being? Now, that's the end of the show because that question's particularly long.
Exactly.
There's no more time left.
No, there's no
Let's
more
go to-
time. We're out of time.
Out of time.
And by the way, just out of curiosity, is time a constant the way the speed of light is a constant? Because that's how we started.
It is
Here's
not.
what I'm going to do.
oh,
I'm going
okay. All right,
to
there you go.
reshape the question into something
Please.
that's
All right.
1.5 sentences long, and I'm going to hand
Please.
it to Charles. Charles,
Yes.
as Dan knows, different factors affect the rate of passage of time. We know this. Sources of gravity, how fast you're moving, how much mass you are. So, might there be a future time where we can manipulate these factors and make time do? We become the time overlords and make time do what we want.
Doctor Who.
Dan, hey Dan, that was a dope question, Dan.
I think that's what he's after, but I've said it in fewer
I don't
words.
care if that's what he's after or not. That's what he's asking now.
Right.
That's a great question. That's
Right.
amazing.
Right.
Well, look, this is a great question. It's very complicated, lots of great stuff involved. Here's how I think about it. Here's how I approach something like this. Time is a dimension, right? You go back to general theory of relativity. Manipulating time is like talking about manipulating length, width, or height. In other words, we don't manipulate the dimensions itself. We manipulate where we are in that dimension, how we travel in that dimension, which direction we move, speed at which we move, things like that. So the answer really, you're combining two different things. One is the idea of time as a dimension, and the second idea is time as we experience it as humans or as individual organisms or things in the universe. So the answer is yes, we can absolutely manipulate how we experience time in the future. If we could, for example, go near a black hole, we would change our time experience. We can manipulate how fast we move through space, length, width, and height. In the same way, we can manipulate how fast we move through time. Just by picking up our speed, getting close to the speed of light, we know that there's this phenomenon called time dilation. The important thing to think about is, what are you trying to do? Are you trying to change the dimension of time itself, or are you trying to change what we are experiencing or what others are experiencing in the form of time? This latter thing is certainly doable given the right technology, but boy, does the technology have to be pretty darn advanced.
So what would happen is if we do master it, you could have a whole other set of people that we might call time bandits.
Oh,
See
Name's
what I
already
did
been
there?
taken, Neil. Sorry.
Oh,
Yeah.
damn, there's already a movie, Time
Yeah, I know.
Bandits.
Maybe, some other time we could think of something.
Or what was that movie where time was a commodity and you could take it or give it to people? Do you remember that
Oh, yes.
movie?
Starring Justin Timberlake.
Yeah, he was in it, and so
Was
was
it?
the guy from The Big Bang Theory.
Oh.
He was in it too.
Is this the one where everyone had a set amount of time to live, and the moment your time ran out, you would just tip over
You just
and die?
drop dead.
Until then, you would never age.
Right, you never age.
Yeah, and
you could just hand the time. You could buy it or sell
buy
it,
it, sell it.
commoditize it,
Yeah.
get it on the black market.
Right.
Yeah.
That's a classic idea of time, taken to the extreme, of course, of time as a resource, right? If you talk to, say, human resource managers or people who wish to optimize a corporation or an individual's ability to get stuff done, they think of time as a resource and say you have 24 hours each day. How do you apportion it to all the different things you do? How do you make it more efficient? Things like that, right? As a physicist, you might think more about time as a dimension, which is what Einstein considered as the right way to think about it. But
If
there
only
are many
we could
different
put
ways.
it in a bottle.
Time
The
in a
first
bottle.
thing that I'd like to do,
Time in a
if
bottle.
time, wow,
What would you do? What would you do that first thing?
but there
would
never
sing
seems to
it.
be enough time
I would sing it.
do the things, right?
That's
to
right.
do the thing.
Yeah.
Yeah.
Well, time has come today.
Well, at least time is on my side.
all right.
Oh.
And time for another question.
Look at that. And he wins. So that's why he's the champion. Look at that. Goes out with a little Mick Jagger on us.
It is.
All right, Samuel Barnett. Greetings from London. That's London, England.
Oh.
How
Not
about
London,
that?
Connecticut. Okay.
No, not to be mistaken. A bit of a hypothetical question. Given enough advanced technology, would it be possible, I think you're going to like this, would it be possible for an advanced alien civilization to steal our sun before the other side of the world noticed it was missing?
Great question.
Well, yeah, they have 8 minutes to pull off the world's greatest heist.
There you go.
The solar system's greatest heist, right?
Yeah, yeah, that's
But you're
true.
exactly right. Chuck, you're exactly right. It takes 8 minutes for the information that the sun is gone to reach the Earth. The thing is, it would take 8 minutes plus to get the information to the Earth that it's missing. But then the side that's facing away from the Earth, the side of the Earth that's facing away from the sun at that moment would still know right away, like within moments, that it was missing because of all the different things it does other than shine, right? Because of all the different things that the sun does to the Earth other than shine. First of all, the shine is interesting enough, right? Each second, the amount of sunshine that hits the Earth is equivalent to millions of atomic bombs, right? And as a result, you're already removing that heat, and that heat's going to flow completely differently than when the sun is shining. The equilibrium's completely messed up, right? Second of all, the gravitational effect is missing immediately. So the entire Earth would start moving in a direction completely different from what it was doing when it was still in the sun's gravitational field, right? So it might fly straight off into another direction, right? Just like if you let go of a lasso and you let the string go, and then the thing just goes flying straight away, right? You have a brick on a string or something, and you spin it. The moment you let go of the string, the brick heads off in a straight line. All of the Earth would go at the same time in that direction. And so there's all kinds of things that would immediately affect the entire Earth the moment that the information that the sun was gone reaches the Earth.
Or maybe we just finally get a chance to go make out with Mars.
It would be fun, except Mars is heading off in its own direction. Mars is like, I don't want anything to do with you, Earth. I'm headed to Venus.
All the planets will
All the
fly
planets
off in a
will.
tangent.
Yeah.
What about when you talk about that flying off in a tangent, since Jupiter has so much mass nowhere near the sun, is it possible that we might, one planet or two planets, kind of follow after Jupiter? because of the amount of gravity that it
interesting.
has?
Excellent question, Chuck.
Mm.
I would say that you would have to do the calculation at that precise moment, right? Because the positions of the planets relative to one another keep varying on a second-by-second basis. They all orbit at different rates and at different distances from the sun. But if at the moment that the sun disappeared, the planets were within Jupiter's sphere of influence, in other words, we weren't at escape velocity with respect to Jupiter, then indeed we would start moving toward Jupiter, and there's a real possibility that we would wind up orbiting Jupiter after a long period of migration.
Right. You can picture if we're on one side of the sun, headed to the left, and the Jupiter's on the other side of the sun, headed the other way, and then we lose the gravity. Jupiter's in one direction, we're in the other, so we're not catching Jupiter at that point.
That's right.
So,
Exactly, right,
Yeah.
right.
So right, Charles. You'd have to really, you can probably do the math on that and see
would
what
not be
planets
too
would get
hard.
together after
Yeah,
that.
it
That'd
would
be a
not
fun-
be too hard to do the math, but it would be really cool, actually.
that would be
I don't want to try it. I don't want to try it.
No,
but
This would be the
I think
Sun
it would be
Bandits.
really neat.
The Sun Bandits.
Oh,
Yeah. So, guys, we got to take a quick break. When we come back, more StarTalk Sports Edition Grab Bag Cosmic Queries on StarTalk. We're back. StarTalk Sports Edition Cosmic Queries Grab Bag. And you know I need help with the grab bag. So we got Charles Liu, our geeky
Hey.
chief,
Yay.
with us. And by the way, StarTalk fans, we retooled the categories of our Patreon membership. And so I want to see what those new categories are that might entice you if you haven't been a Patreon member before. This new structure might resonate with you. And of course, you'd find that at patreon.com/StarTalkRadio. So check that out. Because all the questions we were responding to today are from Patreon members. That's one of the
right.
privileges and one of the perks.
All right, so stop sending them to me and join Patreon.
Okay.
Stop trying to game the system.
Game the system.
Yeah.
All right. And so, Gary, this is StarTalk Sports Edition. When do we
Yes.
get into the sports questions?
Oh, you're so impatient. We're going to get there.
Sports.
Yeah, go sports. Segment 3. But
Segment
there
3,
is-
I'll look
Yeah,
forward
but
to that.
our Patreon audience are so inquisitive. Their cosmic curiosity is so deep and intense. I felt the need to just bring that forward and
Okay.
not just hog all those questions
All right,
for
get
sport.
warmed
So-
up with the actual universe.
all right, we're going to go off
Okay.
and do our stretches. And we'll
All
be
right, let's
ready.
do it.
All
Next
right.
question.
Next question up. Nefertiti? Yeah. Okay, I might mangle that one. So, which of the laws of interesting question this? Which of the laws of physics could you change and have the least effect on everyday life?
Oh, geez.
Ooh.
Oh, wow. Well, they're also interconnected, right, Neil? I mean, I don't know if you can tweak any one thing and it not just like totally unravel the entire tapestry of the earth and the world and everything we do.
Yeah, I got to agree
Yeah.
with you, Charles, on that.
Yeah.
They're so interconnected
Right.
that if you change one thing, that's the beginning of the end of everything you know and love in this world.
Right.
All right, how about this one? Let me give you guys my example, just
Okay.
out of craps and giggles. Okay. For every action, there's an equal and opposite reaction. Suppose we made the reaction opposite but not equal.
Yes.
Ah.
You see
Well,
what I'm
already
saying?
in reality, we have these things called friction and viscosity, right? They dissipate some of the action when it comes back. So to some extent, it is a lesser reaction, like by a tiny fraction, if you take these dissipative forces into account. So maybe if it were a tiny, tiny bit different, that's a great point, Chuck. It's very possible that we would not notice. So it would have to be a very small change, but maybe, if it were at the 99.99999% level true, and then you just had a tiny, tiny fraction of percent dissipating, we might not be able to tell on a daily basis because all the rest of our interactions are so large compared to that fraction.
Are you saying, Neil, that and Charles, that there is a natural tolerance, albeit a small, very tiny one, in the laws of physics, or are they it's
Possibly,
that and nothing
right.
else?
and that may be the point, right, Neil? I know you're about to say something along these lines, but if the constants of the universe, gravitational, speed of light, whatever, were all tiny, tiny bit different, like different one part in a billion or something, maybe in our daily lives we would not notice. But over the history of the universe, things would be so fundamentally changed that our existences would just not be the same.
Yeah, or we wouldn't exist at all. I'll give an example. There's a fun calculation you do in astrophysics graduate school. And I know the word fun and calculation are not always in the same sentence.
Bring it on.
What you do is you ask yourself, suppose the gravitational constant, this was predicted to exist by Isaac Newton, ultimately measured by a fellow named Cavendish, and this gravitational constant, if it was slightly different, what effect would it have on, for example, the luminosity of the sun?
Yeah.
Okay, because the sun's the weight of all the mass and the pressure and the temperature and the nuclear reactions, all of this. Yeah. When you do that calculation, you find that the luminosity of the sun depends to the 7th power on the gravitational constant.
Damn.
Yeah.
So if the gravitational constant was a tiny bit higher, then the luminosity of the sun would be unacceptably high for anything we enjoy and love here on Earth in our Goldilocks zone.
Yeah, I remember that calculation, Neil. That's fun. I know we didn't go to grad school together, but it's that mental exercise, and I remember thinking, wow, if we just change the gravitational constant of the universe by 1/10%, then the surface of the Earth would be uninhabitable.
Right. Right.
Oh,
So it's not that everything is in delicate balance. Don't think about it in those terms. It's that we are what works with the properties that exist in this universe. Right? Yes, and if you change it, we're not here, but maybe something else would be here in those other under those other conditions, but it wouldn't be anything we know and love.
Oh, well, there you have it. So your answer is if some butts were candies and nuts, every day would be Christmas. So
yes, that's exactly what we said.
You know what?
Sure.
If you want to talk about the Big Bang Theory, that's a great point. You know what, Chuck? Because if the expansion rate of the universe were different, then it would not affect us as much during the lifetime of human beings on the Earth. Right, Neil? If the Hubble constant were, say, half of what it is now or double what it is now, then it wouldn't make a big difference billions of years from now. But at this moment in the evolution of our society and of human civilization, it would not make that big of an effect.
I worry that if the Hubble constant were too high, then in the early universe, the matter would not have coalesced.
Right.
We would have expanded and then never formed stars and galaxies.
Yeah. It's a before thing instead of an after thing.
Right. And I'm just saying there are people who get religious about this and say, oh, you see, everything is perfectly tuned for us. No, we are perfectly tuned for it. That's the difference.
All right.
Oh, by the way, one other thing, quick thing. You mentioned the Big Bang Theory, and if and buts were candy and nuts. What was that thing?
It'd be Christmas every day.
It'd be Christmas every day.
My first of 2 cameos on the TV sitcom Big Bang Theory, Sheldon recited that very same poem to my face.
Oh, really?
Yes.
That's
awesome.
why I know it, Neil.
That's very cool.
First time I ever heard that, actually.
Yeah.
All right, here we go. Let's dive in even deeper. Joey Medici has inquired, could a body of mass have 2 different strengths of gravity? Think a giant meteor or a planet shaped like a cone. Would the end with more mass have more pull? And then finishes up with thanks.
Charles, let me take this one. I got this one.
Go for it.
So, yes, first the answer is yes. Generally, when we do calculations, we simplify it and we talk about objects that are spherically symmetric, not only in radius, but in distance from the center. And so that makes the calculations come out easy. But geologists, geophysicists, oil prospectors have gravimeters where they're looking for distortions in the overall average gravity of the Earth that will tell them where something heavier than the normal gravity or lighter than the normal gravity might be found. And that's how they found the undersea crater from 65 million years ago, which was the smoking gun that took out the dinosaurs from the asteroid that hit in the Yucatan Peninsula. So if you redistribute matter, the cone is an extreme example, but if you redistribute it any way, we have the power to find out where the extra mass deposits are versus where they're not. And yeah, the gravity is not always just coming, quote, from the center.
That's right. No, Joey's point is a very good one. And it shows up in other astronomical activities too. So for example, when we try to send spacecraft to orbit asteroids or other small bodies in the solar system, we have to take into account the fact that at every different point in that spacecraft's orbit, it is experiencing a slightly different gravitational acceleration from the asteroid because the asteroid's shape is not perfectly uniform and spherical. Yeah, so the gravitational constant of the universe stays the same no matter where you are, but the distribution of mass and how far away you are from that distribution affects the gravitational force you feel all the time.
You got
So
it.
let me ask you this. Is there any part of astrophysics where the answer is, that's good enough?
Yes, yes. My
It's like all your
my
calculations are so precise.
my thesis committee said precisely that, on whether or not they wanted to give me my PhD. Close enough.
Oh, that's terrible.
There we
Stop
go.
it. You stop that now.
Continuing with a kind of earthbound and slightly geophysical approach, David Williams has asked both Neil and Chuck, how far do you predict the tectonic plates will move or churn before tectonic activities stop on Earth?
You'll be dead. That's the answer. Don't no.
Yeah,
I don't know why.
So Charles, let me offer you a fast back of the envelope.
yeah. Go for it. Go
Okay.
for it.
So Mars has, is it 1/8 our surface area? Is that right?
Roughly.
I think roughly 1/8 our surface area. And generally you radiate the heat through your surface. Okay. Mars has no tectonic activity. We think it may have at one point, but it's completely cooled. So I'm just wondering, maybe we have to be around 8 times as long as Mars has been to reach the state that Mars is in right now, or whenever Mars had stopped its activity. What do you think of that back of the envelope
I think
calculation,
that makes a
Charles?
lot of sense. The general consensus right now is that Mars's tectonic activity stopped about 1 to 2 billion years, I believe, after it formed, which means that we have somewhere between, say, 10 and 20 billion years worth of tectonics going on in our Earth before we run out of internal heat. If we do that right now, we're at about 4.5 billion. So the tectonic plates currently move at about the rate at which your fingernails grow. That is an inch or two per year.
Wow.
So if you go a couple inches a year and you go for 15
Wait, Charles,
billion
you never been
years-
to a black salon? The nails grow way faster there. I'm just telling you.
They can grow in as quick as 5 to 7 minutes.
Oh,
Yeah.
A little bit of glue and you're all
yeah,
in. No.
that's right. You right.
Okay.
thank you for providing me that extra context there.
Walked in looking like Nubs, walked out looking like Freddy Krueger.
Wow. Well, yeah. So if you go in a couple inches a year for about 15 billion years, then that's a pretty fair distance you could travel. Now, the caveat, of course, as we all know, Neil and Chuck and Gary, is that 5 billion years from now, the sun is going to go red giant, and the solar system and the entire Milky Way is going to crash into the Andromeda galaxy, right? So by then, I don't think tectonics will be an issue. Yeah. So
Yeah, there you go. So how would you like to die? Go ahead. Pick
But it
your
also
poison.
means, just to be clear, if Earth cools off, there's no volcanoes.
Right.
There's
That's
no earthquakes.
That's right.
There's none of that.
that's right.
That
There's
whole
none
ring
of
of
that.
fire, all that ends. Yeah.
That's right.
And would
Yeah.
mountains continue to
No,
grow and
they'd be end. That'd be
that'd
end of
be
mountain.
the
That's
end of
it.
everything, right? Okay.
Well, you
Wow.
could just look at Mars to sort of see what happens once there's no more plate tectonics, right? Or the moon, for example. They have these things and they sit there and they're big and they just don't ever change.
Right.
Oh,
All right. Okay. On that cheerful note,
that's boring.
the The next question comes from Captain James Riley. So I'm guessing that's a title we should appreciate. Why don't we have a deep sea base yet? If we want to explore alien worlds, we've got some right here, and that we just seem to be not interested. So he's encouraging now. Come on, Elon, let's go to the bottom of the ocean. I'm saying Elon. It's more a James Cameron thing, isn't it? So,
So I bet Charles and I agree on this, but I'm going to lead off, and Charles, I'm going to hand you the baton.
Please.
It is way easier to go into space than to the bottom of the ocean.
Yeah.
Charles, that's my handoff to you.
It is not necessarily way easier. It is easier in some ways and harder in other ways to go into space compared to being the bottom of the ocean. But I believe that the main reason we haven't gone down as much as we've gone up is because there are, shall we say, social and political advantages to going up as opposed to going down. If you want the high ground, and companies and corporations and countries are always looking for the high ground, you don't go down to the bottom of the ocean. You go up into orbit. You go up into space.
Well, okay, but however, in the Second World War, the low ground was the realm of submarines. And
yes,
so
but who do you think made a bigger difference, the submarines or the airplanes?
Yeah, the airplanes for sure.
Yeah.
It depends on which movie you're watching. That's.
I did like, Das Boot was
Das Boot and
awesome.
Red October
Yeah.
and
Exactly.
Crimson Tide.
Crimson Tide, you know?
We got them all. But so what are the pressures at the Marianas Trench?
Wow.
Well, let's see. Every time you go down about 32 feet is the equivalent of one Earth atmosphere at the Earth's surface.
Oh my gosh.
So if you go down 35,000 feet, that's more than 1,000 atmospheres. So that's 15,000 pounds per square inch.
Right. And the difference between one atmosphere and space is one atmosphere.
That's right. So there is a structural
That's kind of my point about space is structurally.
Space is not trying to crush you like a grape.
And yet we have sent things down into the Marianas Trench, and they have come back.
They have.
Right?
Okay.
So
they're flatter when they come back, but guys, we got to take a quick break. Quick break. When we come back, more StarTalk, Cosmic Queries, Sports Edition, and Gary promised us we're going to get to some sports questions.
We
in the third
will.
segment.
Yes.
When we return on StarTalk. We're back, StarTalk Sports Edition, Cosmic Queries Grab Bag. I got Charles Liu with me. Charles, what projects are you working on now?
Oh, this is quite a year for me. Thank you for asking. Scientifically, we're about to launch into a lot of work with my JWST, James Webb Space Telescope, and Rubin Observatory colleagues. Got some projects that are ramping up now.
So you can talk to us as developments continue to roll off the off the assembly line.
It'll be a pleasure. And I'll be talking a little bit about that too in season 2 of my podcast, The Luniverse with Dr. Charles Liu, which will be dropping soon.
Oh my God! All right,
Yay.
the Luniverse. I love it. Love it.
I didn't come up with that name, but I like the name.
Where all fine podcasts are found.
Indeed.
Yeah. All right. Let's keep going. Gary, what do you got?
Okay, I can't do this name as much justice as Chuck, but I'll have a go at it. Alejandro Reynoso of Monterrey, Mexico. Sorry, Alejandro. I just cannot compete.
Yeah, you just can't do it.
I just can't compete with Lord Nice. Not a chance.
Okay, all right.
All right. He wishes us well and has a question. How the weather affects a football match? For example, when it's snowing, is there anything players can do to compensate? So the natural elements affecting an outdoor game.
Yeah, first, the NFL's gotten wimpy because they always put the Super Bowl, which takes place in January, February, in some southern climate.
The Super Bowls were always held in warm climates before they had internal stadiums. That's true.
Okay,
but there were NFL championship games, right? The very famous one a long time ago, Green Bay Packers. The Bart Starr, he like crushed up and he looks old and stuff.
What was it called?
There
the Snow
was
Bowl?
a Super Bowl. There was Snow Bowl.
Yeah.
There was a Super Bowl held in New Jersey one time, not too long ago. They tried to do that. Didn't work out so well.
It was terrible.
And of course, Peyton Manning was crushed 34-8. I'm so sorry to say. although he did in fact eventually get a Super Bowl win later with the Denver Broncos. So, he retired out. Anyway, too much. Okay. Yes. If you have a problem with the weather, you have to adapt.
Yes.
If it's American football, right, you have to throw the ball a little bit shorter, a little bit faster. If you are running the ball, then you have to wear different shoes, or you have to change your step a little bit. There's lots of things that you have to make adjustments for.
So Charles, the ball's not as sticky when
correct.
it's very
it's also
cold.
harder, right?
It's
So
harder.
the surface,
It's harder.
Yeah, it's harder to move, and it's almost
Not
as if it were,
not if
say,
you let some of the
inflated
air
a little
out.
bit extra.
No, let some of the
Just
air
let
out.
some of the air out.
Yeah,
of it. It's
why
so
not?
fun.
It took you
Inflate.
that long to get there.
Inflate.
Really?
Why not?
You know?
Well, no, but Charles, in
Yes.
automotive,
Yes.
all right, in winter, whatever was the pressure in your tires,
Yes.
it drops just automatically because
Yes, it drops a little bit. That's
it
right.
drops a little bit. So you have to put extra air in your tires over the winter to maintain your standard tire pressure. I presume in the football, they got to put more air in to get the same, was it 6 to 9 pounds of pressure per square inch or whatever that is?
Yeah, you do. And as a result, the way you inflate or deflate a football, depending on the temperature or whatnot, or whether the quarterback likes it this way or that.
Or if you had
I mean,
high
in
altitude
fact,
or low
I need the
altitude.
ball
That's
to be
right.
just a little squishy.
Yeah,
I need the
can
ball
in
to
fact
be squishy.
affect things, right? And that's not allowed. Okay, it's not allowed. There's a range, and if you want to exceed that range, and because you want to have an advantage, or you feel better throwing the ball or catching the ball, you're not allowed to do that. That's just not part of the rules.
Exactly.
But yes, you have to make adaptations as a player too. And if you're a non-U.S. football player, I don't know how often you play in the snow, but I can only imagine how hard it is to play in the snow there.
Yeah,
I
I mean,
remember
if it's fresh snow, Charles, what they do is they clear the lines on the field, so as you can see the lines, but they'll invariably leave the snow as long as it doesn't get too deep. But there is a kind of guideline: can the ball roll through the snow? So if the snow's compacted and it can roll over the top, then they'll play. If it's too deep, they won't play. If it were, for instance, if it's really windy, you will not kick the ball too high in the air because it's more at the mercy of the prevailing winds. So if providing there's no snow involved, you would keep the ball on the surface and not get it up too much. If you think it's going to be like wet or snowy, then and it's not too windy, then you get it airborne more because then it doesn't get stuck, getting caught in the
So
wet
it's the whole
surface or the snow.
strategic-
Totally.
Okay,
You would. It's adapt and survive. It's a simple principle. You change the style of game you have to accommodate for the weather.
One of our producers for this segment, Lane, both she and I, not at the same time because I'm like way older, we both rowed. And one of the things we know when we're rowing, you've seen rowers on the river, perhaps, as the oar goes into the water, they do what's called, they feather the blade. So the blade goes into the water, comes out, and it gets feathered so that when it moves backwards against the air, it reduces the air friction, and then it feathers back and then goes in. So this rotation of the blade is to reduce air resistance. However, if you have a tailwind, you don't feather because,
Yes.
Right,
because the blades then become your
a
sail.
sail.
Yes. Yes. So there are tactical changes that you invoke depending on how this works.
And
Okay.
if you're in Wisconsin on a lake, then you don't go anywhere because
You run. You run.
Frozen solid.
Get your skates out.
That's right.
So the other thing, Neil, is if you're a track and field athlete and you're a thrower, and there's a crosswind, you then use that, but you have to use it to throw into, so as it then brings you back into the center of the arc that you're
Possibly,
trying to land.
but the discus actually famously goes farther into the wind than with the wind.
Yeah.
So because it becomes an airfoil and it coasts on the uplift.
With javelins, no. I mean, if
I don't think so. Yeah, I don't think so with javelin.
No, I've had the experience of throwing javelins. So I got caught in a crosswind, and it was just
Listen to
blowing
you,
the whole
Mr.
sphere out.
Olympic athlete. Listen to you.
Not an Olympic athlete at
Well,
all.
when I threw a javelin, yes. When I stepped out of the Grecian urn, when I was modeling for the Grecian, the Greek potters gave me a leave so that
Yes,
I could.
that's right. To protect my modesty.
All right, give me some more here.
Let's have another question here. All right, this is from Bill Williamson, and greetings from Essexville, Michigan. Never
Wait,
knew
that means his name is
existed.
William Williamson.
Yes.
Yeah.
Just checking.
Or Bill.
Okay.
All right, survival programs and competitions have occupied a special niche in American TV for a while. By survival here, I mean programs such as Alone, Not Survivor. It's a rather long question. Let's see. I can't recall hearing anyone talk about how expertise in physics might shape a contestant's choices of survival gear. Once watched Les Stroud light a fire with a parabolic mirror that he fashioned from the bottom of an aluminium can. That
Les Stroud is superhuman.
Right,
that guy.
Now
Pretty amazing.
the curiosity now comes: what non-standard survival gear or preparations would us as gentlemen might take to demonstrate the value of scientific knowledge and know-how in the survival situation? Okay, look at this. We're stuck somewhere we don't want to be, so we need to navigate. We quite need water for survival. We'll need food.
Wait, are we naked? Like in Naked and Afraid?
I hope not, but
That's a survival.
I haven't ruled it out.
It matters, right? Because you want to freeze.
So we are.
Right.
So we
freeze your gonads.
So
right?
here we go. Be good if we had a sextant. We could navigate our way out of a bit of or knowledge of astronomy, so as we could possibly navigate our way out of there. Water. So could we then generate something from condensation?
Sure.
So
No
that
problem.
way's there, and then we got to hunt and gather. We got to go back to stay alive and go and find in nature what it is. So a knowledge of botany and or the flora
Botany, so
and
you know
fauna.
how to not die from your plants.
Yeah, don't eat that. That'll kill you. That kind of basic stuff. So what do we think, gentlemen? What could we bring scientifically to survive in the great unknown?
I would bring my
outdoors?
smartphone that has Uber Eats on it.
Okay.
Exactly.
All right. That's great as long as you get a signal.
I'll tell you what I'm bringing. Speaking of along Neil's lines, a satellite phone. That's what I'm bringing.
Okay.
And
That's
I'm
right.
good. And I'm good to go. Come get me. That's it.
Did you see that FedEx commercial? That was a riff on what's that movie that Tom Hanks was in?
Wilson!
Castaway.
Castaway.
Castaway. Thank you.
Castaway. So there's a TV commercial for FedEx, right?
Yeah.
And they showed the Tom Hanks character, right, delivering this FedEx package years later to its address because they always deliver. Okay.
Oh my God.
And she said, "Oh, thank you. It's a little late, but thank you." And he turns away, but then he turns back and said, "I just have to know, what was in that package?" And she said, "Oh, a satellite phone, some seeds."
Oh my God. That's terrible. I love it. That's awesome.
Yeah, maps. Yeah, that's all that was in it. So thank you.
That's great.
So I would say, I would take a cue from the movie that presumably was in the book as well, Black Stallion. Okay, and in that, the little boy who survived, he learned from his father. He says, "You always want a pocket knife."
Yep. I was going to say, I want a giant knife and a magnifying glass. That's what I want.
Yeah, a knife, because there's nothing on our body that can do what a knife can do.
Right.
Right? And so your teeth sort of, but not as well. And so that would be the one tool that if you had to have a survival tool, that would help. And a magnifying glass, certainly you can make fire at any time. Otherwise, you got to do it the caveman way, which is you can still do it.
Yeah, screw that string and sticks crap. I'll never forget that string and stick crap. I want a
remember
magnifying
that.
glass and
Right.
a giant
Remember.
knife.
remember what a knife is, right? In physics, it's a simple machine. It's a wedge.
Yeah.
It's a very, very sharp wedge.
Right.
And so that is physics, right? And then
Charles,
the
tell
other thing
us
I would think
what the
about
5 machines are, just while you're going
the
there.
5. Oh, there's the pulley thing. There's a wheel and axle thing.
Yeah.
There's a wedge thing. There's a lever thing. And
an inclined
there's
plane.
an inclined plane thing.
Yeah.
right.
Yeah. These are the 5 basic
Yeah.
machines in physics. And these
Yeah,
are machines
so-
that will take energy invested at one rate, and
work.
it changes the rate on the other end at which it gets invested. So the screw, you left out the screw, didn't you? Or is
No,
that
the screw is a wedge that's been coiled.
That's a wedge.
Right?
So it's how you can crank a car, right?
Right.
Yeah.
Because you're not strong enough to lift the car, but you could move something the equivalent of yards in distance, and then the car moves up an inch.
Yeah.
Right? So it took
That's right.
all that energy to move it, and then it packed it into that 1 inch. So it changes the ratio of invested energy. So,
That's right.
Yeah.
So cool, so cool, so cool. Yeah, the knife is the thing, man. And, when you think about it. Think about how many foods that grow wild that we can't eat because we don't have the strength or the teeth to cut them open. And a knife just allows you to go ahead. Coconuts. I mean, you got
Right.
you got a knife, man. You know, you're good to go.
Yeah.
Well, I would also want actually some sort of a blanket. Maybe one of those thermal mylar-based blankets to keep myself warm.
See, but with a
Those
knife,
are very small.
with a knife, you can kill and skin a bear, and you got a coat. Now you got a coat.
Yeah, but it smells
And a
bad
shawl,
until you run
and
it
all
through
the
the
Oh,
Yeah.
dear.
The blanket, like these mylar blankets, the space blankets things, right? They're very warm and they fit into a pocket. Once you fold them up, they're
This is what
very,
they
very
give to the
small.
marathon runners
Right.
when they finish
Right,
the race.
exactly.
Right,
Whereas,
right.
bears are very large. They don't fit in your pocket all that easily. So
Yeah.
it's going to take a while. Not to mention,
Chuck,
you have to
I'm not
hunt it
sure I
down.
want to bring a knife to a bear fight. Really, just can't see that working out well for me.
Yeah, that's not so fair.
All right, let's try to fit in like one last question.
All
here.
right, James Parrish here. He's in Birmingham, Alabama. Picture, if you will, a hitter that knows for their speed and proclivity to slide head first. Think about a Ricky Henderson or a Pete Rose, for example. And they're at bat. They hit a little dribbler down to third baseline. A third baseman charges in, bare hands the ball, and makes a throw to the first. It is going to be a close play. Will our speedster reach first base quicker by diving for the bag or running through the bag?
Oh, a classic.
So
classic
here we
question.
go. What
Charles.
is our
Classic debate.
physics?
Settle this,
Okay.
Charles.
All right, here's the physics of the situation. You will go faster if you are running than when you are diving. General. However, if you're trying to go a very short distance very fast, the dive can help if you launch yourself with both feet off the ground, giving yourself that extra little propulsion for that short distance that you're airborne before you hit the ground. So if you are, say, inches away and you want that last little extra bit, go ahead and dive. But if you are trying to make up a few feet or even a foot or something like that, keep running.
Wait,
Now-
but Charles, your 2 feet are never together when you're running.
That's
So
the thing.
that's
You-
not a realistic situation.
That's right. So
Right.
you have to find a way. If you're going to make your dive, you got to put both feet into the final propelling push. And so that's why
So
when
that you
normally-
would go faster than you would have had you been only been pushed forward with 1 foot at
Correct.
any given time.
Correct.
Mhm.
Now, here's the important caveat, right? When we are horizontal, we are a few feet longer than when we're vertical, right? So when Ricky Henderson used to dive, what he was gaining the advantage of was twofold. One, he would be ducking below the tag. And
But that's
second of all,
why this is specifically for first base.
That's
where
right.
You're not
And
tagging the
second of
runner.
all, Second of all, he's got that extra 2 or 3 feet horizontally to touch the bag with his hands that he otherwise would have had to do with his feet because you have to stop. Right. He used his belly to slow himself down without having to use the slide effect. I wonder if Ricky Henderson and some of these headfirst divers actually wear like thicker uniforms to
Wait,
prevent
Charles, we're talking
themselves
about
getting
first
squirted.
base. You don't have to slow down going into first base.
If you're talking about first base,
That's the question.
then-
And
right.
And our boy knew that in the question, right?
Now,
This is
yeah,
not
he knew
avoiding
that.
a tag. You're not slowing down so you don't overrun it. And so, well, how about this, Charles?
Yeah.
there's when my head would have reached the bag, but there's when my outstretched arm would have reached the bag, because I can extend my arm faster than I can run.
That's right. So if you can coil yourself up in such a way that you give yourself that last 2 or 3 feet, right, going to first base, fine. But usually it's not. Think also, most runners are still accelerating when they get to first base, right? If you're running a 100-yard dash, you don't actually reach your maximum speed until
later in
later in the race.
About 30 meters,
Right.
yeah.
So the distance from one base to another in Major League Baseball is 90 feet, right? So you've got 30
That's
yards.
only 30 yards.
Basically.
That's only 30
right.
yards.
So you're still speeding up. So you don't want to cut off your acceleration by diving. Once you leave your feet, you're not speeding up anymore. You have to use your body shape, right? Your reach, whatever, to compensate for the fact that you're no longer accelerating.
What Charles is saying is anyone who slides into first base is a physics idiot. That's what he's saying.
That's basically what he said.
Unless they understand the concepts of rigid body motion and flexible body motion and moments of inertia, in which case they could actually gain a slight advantage.
Okay.
Would it be advantageous to go feet first in a slide rather than head
and
first?
here's what I'm going to say. Anyone who understands moments of inertia and rigid body motion is not diving headfirst into space.
That most likely they will have already done such a good job hitting the ball that they would just be able to coast into first, round the base, and decide whether or not to take second.
There you go.
All right. Well, thanks for this bit of insight here. And yes, it matters whether it's first base or second for this question, of course.
Right.
But guys, that's all we have time
Today. We were just getting into it.
All right, guys, we got to get out of this.
All right.
Land this plane. It's been a delight, Charles Liu, my friend and colleague, to join us once again as
Always a pleasure.
As our geek in chief.
Thank you so much.
Gary, always good to have you there.
Pleasure, Neil.
Co-host. This has been a StarTalk Sports Edition, Cosmic Queries Grab Bag. Neil deGrasse Tyson, your personal astrophysicist. Keep looking up.